Selecting of scaling, repeating variables. The selection of scaling variables is left to the user in the previous section, but there are some guidelines. For example, for equation of Bernoulli equation, constant. It is not clear that the scaling variables in this relation are rho, v, and L, since they appear in both force coefficient and Reynolds number. We could then interpret data from this equation as the variation of dimensionless force versus dimensionless viscosity. Since each parameter in only one dimensionless group, such as the equation for falling body, the scaling variables were selected from, for example, S0, P0, and G, not S3, because we wish to plot S versus T in the final result. In this equation, in the previous equation, we had P0T plus, we select S0, P0, and G as parameters, and S and T as variables. Because we wish to plot S versus T in the final result. The following are some guidelines for selecting a scaling factor for for example, repeating variables. The first guideline is they must not form a dimensionless group among themselves. Form a dimensionless group among themselves. For example, test powers of, in the previous relation we have rho, v, and L for the Bernoulli equation as parameters. So if we use the group of variables as rho, v, L, A, B, C, rho is M, L minus 3A, L on T, B for V, and L for the T for A, L for A, which should give us 9 dimension. In this case, the only way is to A equals to 0, B equals to 0, and C equals to 0, which is meaningless, and in this case we can see only this is so, only rho contains the dimension M, and only V contains the dimension T, so cancellation is possible. If now we add move to the scaling group. In this case of the problem, we have the condition for non-dimensionality. So A, no meaning. So we should add the viscosity in the relation to the scaling group to obtain a dimension quantity, which in this case is Reynolds OVL on mu. It is the non-dimensional number. If we add f to the group, we form the force coefficient. For example, do not select output variable for your scaling parameters. Certainly do not select f, which in this case of problem, if we encounter with the force in a experimental, for example, we should output variables for your scaling parameters. For example, in the equation, f was the relation for rho v L, for example. Do not select f in this type of problem, nor was mu selected, for we wish to plot the force versus viscosity. In this case, plotting is for force and viscosity. The third guideline to the selecting repeating variable is the if convenient, select popular not obscure scaling variables. Select popular scaling variables. Because they will appear in all of your dimensionless group. In all your For example, select density, not surface tension. Select body length, not surface roughness. For example, select density, not tension, surface. Select body length, not surface roughness. The example that follow will make this clear. Problem assignment may give hints. Suppose we wish to study drag force versus velocity. Study drag force versus velocity. Then we would not use v as a scaling parameter in their equation f function of rho, v, and L. We use instead of this equation a function of rho, mu, and L. And the final dimensionless function would become Cf prime rho f and Reynolds equals 2 on mu. This was an example for dimensionless problem and guidelines. The next video is about some peculiar engineering equations.